Hey, psychology students, and welcome. Look, if you're just starting out, I get it. The word statistics can feel a little intimidating, but I want you to think of it in a totally different way. Think of stats as your toolkit for really, truly understanding the complexities of human behavior. And today, we're adding an absolutely crucial set of tools to that kit. So here's our game plan. We're going to start with why we need to look past the simple average. Then we'll open up the toolkit and check out the key measures. After that, we'll see how software makes our lives a whole lot easier, learn how to report our findings like a pro, and finally, we'll see how this all becomes your new research superpower. Ready? Let's jump in. All right, let's kick things off with a simple but really powerful idea. To understand what's going on in your data, the average, or the mean, it just isn't enough on its own. So, check this out. We've got two classes, and both have the exact same average exam score, 80%. But just look at the actual scores. Would you say the performance is the same in both? No way. In Class A, everyone is packed right around that 80. The professor can feel pretty good about how the class is doing as a whole. But Class B, man, things are all over the map. That average of 80 is totally hiding the fact that some students are struggling while others are excelling. This difference, this spread, is exactly what we're here to talk about. And that spread, it has a name: variability. It's the official term for what we just saw. It's a number that tells us precisely how spread out or how clustered together our data points are. You see, it gives us the context that the mean all by itself just can't. So why do we really need to measure it? Well, for one, it helps us describe the full picture of our data. Is it consistent or is it kind of chaotic? Two, it tells us how well that average score actually represents the whole group. For Class A, that mean of 80 was a fantastic summary. For Class B, not so much. And this is the big one. Variability is a foundational concept for pretty much all the advanced statistics you're going to learn down the road. Okay, so we get why it's important. Now let's open up that statistical toolkit and look at the 4 key tools we use to measure it. First up, we've got the range. It's the easiest one of all. You just take the highest score and subtract the lowest. For Class B, that's 100 minus 60, so the range is 40. The good thing, it's super simple. But the bad thing is a huge weakness. It only uses 2 scores, the absolute extremes, and completely ignores everything happening in the middle. We need something a bit more sophisticated. And that's where variance comes in to save the day. See, variance is way more powerful because it uses every single score in your data set to figure out the spread. The basic idea is that it's the average of how far each score is from the mean, but with a little mathematical twist. Let's just walk through the logic here. Don't worry about the complex formulas for now. First, you get the average. Easy enough. Then, for every single score, you figure out how far away it is from that average. Some of those distances will be positive, some negative. So to make all the numbers positive, we just square every single one of those deviations. And finally, we just find the average of all those squared distances. That, my friends, is variance. Now, this is a really, really important point for any budding researcher, so listen up. If you somehow have data for an entire population, you divide by n, the total number. But let's be real, in psychology, we're almost always working with smaller samples. And to get the best possible guess of the whole population's variance from our little sample, we have to divide by n minus 1. It's a tiny little tweak that corrects for the fact that samples are usually a bit less varied than the full population. It gives us a much more accurate estimate. So variance is awesome, but it has this one weird quirk. Remember how we squared all those distances? Well, that means our final units are squared too. So if you're measuring reaction time in seconds, your variance is in seconds squared? What does that even mean, right? It's not super easy to interpret. And that is why we have the standard deviation. It's the simple, elegant solution. We just take the square root of the variance. Boom, done. This puts our number back into the original units we started with, like seconds or test points, and it gives us a beautiful, intuitive number. You can think of it as the typical or average distance that scores fall from the mean. Honestly, this is the most common and most useful measure of variability you will ever use. And just real quick, there's another specialized tool called the median absolute deviation, or MAD. The standard deviation is amazing, but it can get kind of thrown off by 1 or 2 really extreme scores, outliers. MAD is a more robust alternative that doesn't get pushed around so easily, which makes it a great choice when your data is a little messy. Okay, that was a lot of theory. You might be sitting there thinking, oh man, that's a lot of calculation. But here is the absolute best part. In the real world, you'll almost never do this by hand. Let's see how easy this actually is. In amazing, free software like Jamovi, getting these numbers is literally just a few clicks. You open your data, you go to Descriptives, you drag over your variable, and you just check the boxes for the stats you want. Range, variance, standard deviation. Done. The software does all the hard work in a split second. And it's pretty much the exact same deal in another fantastic free program called JASP. Open the data, click Descriptives, check the boxes. And you can see here, JASP even has a simple little checkbox for MAD, that robust measure we just mentioned. The whole process is designed to be as simple as possible. And this brings us to what might be the most important point I make today. Your job is not to be a human calculator. Your real power, your superpower as a researcher, comes from interpretation. It's about looking at that standard deviation number the computer spits out and knowing what it means for your study and how to tell that story to other people. Which leads us perfectly into our next section. Okay, you've got the results. So now what? How do you share them? How do you tell that full story in a clear, professional way? Here is a classic example of how you'd write up your findings in a research paper. Notice how the mean, marked with an M, and the standard deviation, SD, are presented right there together. This is the gold standard. You're not just saying one group was more aggressive. You're showing how much more on average. And you're also showing the consistency within each group. See how the violent cartoon group has a much bigger standard deviation? That tells us their scores were a lot more spread out. Now, when you have a bunch of different groups to compare, a table is your absolute best friend. Just look how clean this is. You can instantly scan across and compare the means and the standard deviations for all 4 groups. This is what clear, concise, professional communication looks like. It tells the entire story in just a glance. Okay, let's wrap this up and bring it all home. We've covered a ton of ground, and I really want to end by hammering home why getting this concept down is so empowering for you. You have fundamentally upgraded your ability to analyze data, for real. You're no longer stuck with a single, sometimes misleading average. You can now describe the entire shape and consistency of your data. You can spot how spread out different groups are, and you can tell a much richer, more accurate story with your research. And trust me on this isn't just some topic you learn for one test and then forget. Understanding variability is absolutely essential. From this day forward, every single research article you pick up will report standard deviations. Every statistical test you learn to run is built on the logic of variance. This is a true cornerstone of your knowledge. So, you came in today maybe thinking stats were just about averages. But now you have the tools to see the spread, the consistency, the whole picture. You can see the real story the data is trying to tell you. So the only question left is, what story are you going to uncover?